Section 10.5, we're in day 2. I'm going to do a quick video review with you, and the rest of the time you're going to have to work on your problems. So, for angles in circles, the first one is a central angle. The central angle is super easy. Whatever the inscribed arc is, that is what the central angle is. So if this is 40 degrees as the arc, this is 40 degrees as the angle. For inscribed angles and tangent chord angles, remember both situations have a vertex on the circle. So our vertex is right here and our vertex is right here. And the rule is the same for both of these. Whatever the inscribed arc is, the angle is half of that. So if this arc was 40, and then this inscribed angle would be 20 degrees. If this arc over here was, let's say, 50, then this angle right here would be 25 degrees. Okay, next one. We have a chord-chord angle. So let's talk about this angle right here. This angle would be, let's say arc DC was, we'll say 70. And over here, arc AB would be, let's say, I have no idea, 20. Let's make it up. All right, the measurement of that arc, you would add 70 and 20. So it's the sum and then half of that. So you multiply by half. So you would end up with 1/2 of 90, which makes it 45 degrees. So this would be 45 degrees. Okay, for a secant-secant, a tangent-tangent, and a secant-tangent angle, all of their vertices are outside the circle. So outside, outside, outside. And the rule is the same for all of them. You take the arcs, you find the difference of the arcs and take half of that. So let's just say we did an example like this on Friday in your notes, but let's say this was 60 and this was 15. So then the angle would be, angle P would be 1/2 60 minus 15, which is 1/2 of 45. So your angle would be 22.5 degrees. Same thing with all of these. Tangent-tangent is kind of unique because it's half the difference of, you have two arcs, but truly those two arcs add up to 360. So let's say that this one was, and this is actually, let's do an example like this. Let's say I only gave you from SXT, and I said this is 240. What is the measurement of angle P? Well, for this one, the measurement of angle P would equal 1/2 240 minus the other arc. You're like, I don't have the other arc. Well, in a tangent-tangent, like I said, both of those arcs are going to be the whole circle. So we need to take 360 minus the 240. I get 120. So that means this is 120. So now we have 240 minus 120. So we get 1/2 of, and what do we have there? 120. Again, half of that gives you 60 degrees for the measurement of angle P. All right, last one. For our secant-tangent angle, let's make it a little bit more complicated. Let's say arc QT is 98 degrees. And we'll say that arc QR is 102. So we need to figure out the measurement of angle P. Well, to do that, I need to know arc QT, which I know, but I also need to know arc RT, which I don't know. But I know that if I add up arc QT plus QR plus RT, it's the whole circle, and it equals 360. So let's do that. We have QT, which is 98. We have QR, which is 102, plus arc RT equals 360. So when you add these two, you get 200 plus measurement of arc RT equals 360. And then when you subtract the 200, arc RT is equal to 160. So let's write 160. The rule for finding a secant-tangent angle is that angle, measurement of angle P, is equal to 1/2, and then the difference of the two arcs. So we have 160 minus 98. So that means we have half of, what do we have, 62? Which gives you a measurement angle for angle P of 31 degrees. All right, so that was a very quick review. You are to complete the rest of this assignment. You can read the little comment, and I will upload the video links for every single problem. If you need a verbal explanation, go to the doc that has all those videos on them.